All right, good morning. Good morning. Hope you all are doing well. So last time we started looking at operator overloading, and we looked at the coordinate class, which was really just a good example to kind of showcase all of the different overloaded operators. And we started to see some of the recurring patterns. So a lot of the functions were set up in a similar way to the others. So for example, we saw that all the arithmetic operator functions were very similar, where we had them all returning a coordinate object by value, and then the body was really just one line, right? For most of them, just return a new coordinate object, right, where you've set X and Y properly, whether it's, if it's two coordinate objects that you're adding, then you need to add the X coordinates and have the Y coordinates. Or if it's negation or unary minus, you're negating X and Y. And then we looked at some of the other operators as well, such as the assignment operator or op equal. And then we'll look at things also like the increment and decrement operators and the input and output operators. And so one of the things that comes up with the issue of the increment and decrement operators is, so we want to be able to, in general, support both prefix and postfix. So with things like plus, plus, and minus, minus, meaning that we can potentially place that operator, right, either to the left of the thing that we're incrementing or decrementing, or to the right of it. And either way, we're calling a function with that exact name. So if it's the plus plus operator, then we're calling a function with the name operator plus plus. If it's the minus minus operator, then we're calling a function with the name operator minus minus. So that means that regardless of whether it's prefix or postfix, right, the function name is still the same. And so we have to have a way of distinguishing the two. And so we'll see how that's going to come into play. So we'll see how things like the parameter list can be different between those two versions, meaning prefix and postfix. And we'll also look at the issue of return type as well. So we'll look at prefix first. So that's kind of the more straightforward one. Because in the case of the chord class, when we talk about an operation like plus plus or minus minus, right, it's going to be involving both X and Y individually. So if we call op plus plus, right, we need to increment X and Y for the current object. Postfix is also ultimately also going to be updating, right, things like X and Y for the current object. But if we do a statement like cout plus plus C1 or cout C1 plus plus, right, there's a difference between those two in terms of the output, because postfix doesn't, the change should not be seen until after the statement is done. So if we do a statement like cout C1 plus plus, right, we should still see the old values of X and Y for C1 before the increment took place. But if we do a statement like cout plus plus C1, then we should see the new values, right? So the increment should happen first, and then we should immediately, see the new values in that same cout statement. So we'll look at how those kind of things can be handled, right? It's just a matter of ensuring that there's a difference in the parameter list just as with any type of overloaded function. And we'll also look at the issue of return type, because we'll see that the return type is going to be different for prefix versus postfix. And we'll see why that's ultimately the case. So we'll go ahead and look at the chord class again. Okay. So we looked at a lot of these operators last time. So this was the H file. And again, when you download this and start, playing around with this on your end, like we mentioned last time, there's going to be a lot of things that are commented out because with a lot of the things that we're doing here, a lot of the operators, we have a choice in most cases in terms of whether we're going to overload a particular version of a function, either as a member function or as a friend function. But what we've been doing here is we've been choosing the member function version when it was possible, right? Because one of the things that we saw in terms of benefits was also that the member function version is right is always going to be shorter compared to the corresponding friend function, because with the member function you have the hidden this pointer pointing at the current object, right? But with the friend function you have to pass in everything explicitly, so you have that one less parameter with the member version compared to the friend version. But as we also mentioned last time, there are those certain cases where um, where you have to pass, where you have to implement it as a friend function, because we saw that sometimes when there's multiple operands, we know that when there's multiple operands, they don't both have to be of the class type, although one of them certainly has to be of the class type. But the other operand, which is not the class, could also be the first or the left operand. So we said to handle that properly, we need to do it in terms of a friend function. We saw that come up in a couple of cases, such as operator plus when you're adding an integer first and a coordinate object second, and then same thing for the other arithmetic operators with that combination where the integer comes, for example, first and the chord object comes second. But for the others, when we had a choice, right, we have the member version active, and then so down here, right in the H file, we start to see things related to the um, plus plus and minus minus operators. And what we're seeing here now, these are all, so this is the public block, right? So these are talking about member versions. But what we're seeing here are two things for operator plus, and we'll also look at what the friend version would look like as well. But we have two things here for operator plus plus, but we'll notice that the parameter list is different between the two, right? Because one, as you can see there, has a empty parameter list. The other has a integer, and then it's also the same thing for these two versions of minus minus. So we have to have some way of distinguishing them from each other. So just like any other version of function overloading, right, there has to be some sort of difference in the parameter list, given the fact that the function name is the same regardless of whether it's called with a prefix type statement or a postfix type statement. So the idea is we use this dummy parameter to help distinguish them. So, the integer that's passed in is not going to be used for anything, but we need to have it there as a way to distinguish it from the other version of operator plus plus. So the first one here would be the prefix version as a member function. So that's the idea with prefix, right? We're just going to immediately do the update, and whereas with postfix, we would still, if we embedded uh, the increment statement within a cout, then we would still see the original values of x and y. Right? So that's going to be the difference here. So again, the parameter here, or really here for the postfix, that integer that's technically passed in is not really used for anything, right? But we need to have something there because we can't have them both be no argument, because then it would be ambiguous. And so we're also seeing, what type of operator things like plus, plus, and minus are, right? Because those are what we call unary operators, right? They just work over the one operand, which is the operand that you're wanting to increment or decrement, which is why, for example, if we're implementing prefix as a member function, there is no parameter list, right? Because, the only argument is the current object, and that's the one being pointed at by the hidden this pointer. So that's what's going on in terms of the parameter list, but let's think also about the return type. Okay. Yeah, so with a function like, yeah, like equal or not equal, um, everything should be constant, yeah, with the operator like equal, and not equal, because those are relational operators, right? And you don't need to change anything, right? Neither the current object, if it's a member function, or the other object. So everything, yes, can be constant with those kind of operators, right? So if it's done as a member function, then the function itself should be constant, and also the other parameter that you're checking against should be constant. Or if it's a friend function, then both the parameters should be, uh, both of the coordinate objects should be constant. Yeah, so everything can be constant with a function like equal or not equal, because that's just returns a Boolean true or false depending upon, for example, whether the two coordinate objects were equal to each other or not. So everything, yeah, really should ideally be constant, because you really want to be using constant with everything that doesn't need to change, right? Whether it's the function itself, which when we know that when you make the function itself constant, that's really talking about the current object, right? Making the current object constant. But also any parameters that you pass in that don't need to change should also, um, if they're being passed by reference, which a thing like a coordinate object should be passed by reference, then it should also be constant if it's not going to change. So yes, for equal, not equal, we can have everything be constant, the function itself and the parameters that are passed into. Here, at least for these things like plus plus and minus minus, that doesn't come up because the object is going to change with either prefix or postfix, and of course we only work over one real operand, which is the current object itself. So that's what's going on in terms of the parameter list here for prefix. So again, prefix is kind of the way we would expect it to be, and then we'll talk about postfix. So nothing passed in if it's a member, and then return type chord ampersand. So like we've seen this come up with some of the other functions here as well, where we've been returning a reference to right, the object itself. So we're going to do that with operator plus plus. Or as we saw before with some of the other functions, it just means it's going to return star this. So that in that sense, it could potentially be used, in a larger expression with cascading and so forth. Now with postfix, though, we can see it's a little bit different here. The parameter is just to distinguish it from prefix. So that's how that int's going to be used. And then we'll see here that this one is returning a coordinate object by value instead of by reference. So that's another difference between the prefix and postfix versions of plus plus, or same ideas we see down here with minus minus. The idea is you have to think about, though, the differences between, how a prefix type operation is going to work versus a postfix, right? So a prefix is the more straightforward, right, in the sense that you could just go in, increment x, increment y, and then return the current object. Postfix is going to have to work a little bit differently because we said, for example, if you do a statement like cout C1 plus plus, you still want to see the old values from before the increment took place. So you are going to ultimately have to still update your x and y for the current object, but we can think about what's going to be returned in this case, because if you just return the current object, well, then you're doing the same thing as prefix, and then it's not really, a true postfix operation. So the way that we can handle this is by not returning the current object. Oh, the dot, that's just some indentation that Visual Studio is putting in. So the dot, yeah, that's not a dot that's actually part of it. Yeah, that's just something that Visual Studio is showing. But the function is just return type chord ampersand, and then the name of the function just operator plus plus. Mm. The dot there is just something that's Visual Studio is adding, but that's not actually part of the prototype. Sure. So that gives you an idea of what's going to be happening here in the case of postfix. So we are going to be returning a copy of the current object, and that copy will be of the current object before anything was incremented, right? So before X and Y were incremented. So we'll go ahead and make that copy, and then we can update X and Y for the current object and then return the copy object. Right, and so that's going to be, in this case, returned also by value, right? Since we're returning a copy, meaning a brand new object, right, rather than a reference to the current object. So meaning that inside of operator plus plus for postfix, we're going to create a new chord object um, and make it a copy of the current object. And then after we update X and Y for the current object, we're going to return that copy object, right? So the copy object itself would be, since it's locally defined inside of op++, right, as usual, is going to be destroyed when that function goes out of scope, but then we're just going to return a copy of it. So we return by value instead of by reference here for the postfix. So that's the idea in terms of what we're doing with postfix plus plus. And it's a similar thing also with postfix minus minus, right? So all the things that we hit on here when we were talking about plus plus, right? They apply in the same kind of way to the decrement operator or minus operator minus minus. So that's the idea. So make a copy object locally inside the function, and then at the end, that object is going to be destroyed, but then you return a copy of that copy object back to the application program to simulate this postfix type behavior. So that's the differences here in terms of how we handled prefix versus postfix. So really was just a matter of having that dummy parameter to distinguish it from prefix, and then also the return type needed to be by value instead of by reference. And it's also, as you might expect from all the other operators that we looked at, it's also a similar thing if we're talking about doing these as friend function implementations. So as you might expect, based on previous examples, if we're talking about for operator plus plus as a prefix, but as a friend, then you would have to pass in, right, the object itself as the parameter, since there's, right, of course, no current object, there's no hidden this pointer. So you'd have your parameter um, as a chord reference type. And then for postfix, you still have to have the integer, the dummy parameter, but then in addition to that, you would also have the parameter of chord ampersand or chord reference type for the object that you're passed in. And then the return types would still be the same, right, for the friend version. So chord object by reference for the prefix, and then still chord by value for the postfix. And we'll see those commented out as well in the chord.cpp file. But that's the general idea for the increment and decrement operators and how we can handle both prefix and postfix. Okay, and then here we start to see the actual implementations, right? Starting below op equal. And so here's prefix, and this is minus minus first, but we'll see that plus plus is the same. So minus minus, we just go in, we decrement x and y, right, and then return the current object. So again, it's similar to some of the other functions that we looked at that had chord ampersand as return type or part of the return type. We saw that with those, if it was a member function, that we were just saying return star this, because we know that this points at the current object, and then if you do reference the pointer, then you're going to get the object itself. So that's a minus minus as a friend or as a member function. So nothing has to be passed in. Then commented out here, we have the minus minus again for prefix, but as a friend function. So the difference only is that now we have to pass in the object as an argument, which we gave the name C here. We passed it by reference, right, as usual. But not constant reference, since C has to change. And then we did the minus minus C dot X minus minus C dot Y and return object C after doing the updates. And then here we have postfix minus minus as a member function. So this one's active. So we know that it has the dummy parameter and then return type chord by value. And so that's what we're doing here. And so just a little bit more compared to the corresponding prefix version. We start out here by creating this temporary copy object. So, and notice there we just said chord temp. We could either do an assignment statement or the curly brackets, since it's a new object that we're creating. But chord temp, and then what we're assigning to it is the current object, right? So we're just making temp a copy of the current object, right? So we're calling the copy constructor, and then we're going to copy everything from the current object over to temp. And then the key thing here is, right, we're still decrementing x and y for the current object, right? So we make temp a copy of the original state of the current object before any changes takes place. Then here we update x and y for the current object, meaning the one pointed at by this, and then we return temp. So that gives us, again, everything that we want in terms of postfix behavior. So it's still going to ultimately update x and y for the current object, right? So if we, for example, see out, if the current object in this case is C1, right, and then we see out C1 after the statement that calls plus plus, we're still going to see the updated values, but now we have that postfix behavior here. So just create the copy object and then return really a copy of temp is what we're returning here back to the application program. So return it by value. And then this would be the postfix minus minus again, but as a friend version of it. So in this case, we have two parameters, right? Because we have to pass in the object itself, which we can still pass that as a coordinate object by reference, but then we're still going to have the integer as the dummy parameter, right? To distinguish it from the prefix version. So postfix minus minus or plus plus is going to have two arguments if you do it as a friend version. So chord object first, and then the integer dummy parameter second. And then similar idea, right? Except we're working off of C instead of the current object. So chord temp, make that a copy of object C. So call the copy constructor, copy C's fields to the new object temp, and then update X and Y for object C, meaning the object that we passed in, and then return temp, which is a copy of C's original state before X and Y were decremented. And then down here we have the block for all the version combinations of plus plus, but it's the same thing, right? Except we're saying plus plus x, for example, or plus plus c1 dot x instead of minus minus. But other than that, right, the logic is really the same for the various versions of op plus plus compared to op minus minus. Okay, so any questions so far? Okay. Most of them can be done either way, although we saw a benefit to doing it as a member function when you can, is that it has less parameters, so a little bit less code. Most of them can be done either way. There's a few like the assignment operator and as we'll see later, the bracket operator that have to be done as a member function. And then we saw cases where you had to do it as a friend function. The idea there, really the rule there was that if the first parameter is not the class object, which sometimes that does come up. So, and when we say we're in that case, we're talking about a binary operator, right? So if it's a unary operator, then certainly if you're only going to have one operand, right, the one operand has to be of the class type, right? We can't, have something that only works off an integer if we're talking about operator overloading. But when we have those binary operators, if the first one is not going to be a class object, meaning the left parameter, then that has to be handled with a friend function, because we know that this pointer is always pointing at the, in terms of a member function implementation, the first parameter is always the current object. And but with things like, for example, the integer plus coordinate object, like a statement like C1 equals 5 plus C2, well, there's really no way to handle that, right, in terms of a member function, because the first parameter there is of type integer. But for it to be able to work as a member function, right, the first parameter, meaning the one pointed at by this pointer, of course, has to be the current object of type chord. So that's why we saw that for those kind of cases, we would just handle it in terms of a friend function. So that meant things like any of the arithmetic operators where you have an integer first, for example, and a coordinate object second. All of those were handled as friend functions because of that rule. And we'll see the same thing come up again with the input and output operators, right? Because that's another case where the class object is not going to be the left or first parameter or first operand. So that'll be another case where we end up having to do it as a friend function. So in terms of what we've seen so far, that's kind of the general idea in terms of when you know that you have to do it as a friend function. You know that you're going to be doing that, certainly if that first operand is not of the class type. Outside of that, for the most part, you have a choice. Although we'll see that things like op equal and things like the subscript or bracket operator have to be done as a member function. Now let's go revisit operator equal, which we talked about the general idea of this for the most part last time, but there was one extra detail here. So operator equal, right, if you look at what we did here, So we have the word const showing up in two different places. Now, this is a member function, right? Because this one has to be done as a member. So C is referring to the right-hand side of the assignment statement, right? Which we know that that's not going to change. So we can go ahead and pass that by constant reference, as we've done with many of these functions. Of course, the current object is going to change, right? Meaning the one pointed out by this pointer. So the function itself is not const, although we do have a const showing up in the return type. And in fact, so it's still a reference return type, but the return type here is const chord ampersand, or return a coordinate object by constant reference. And this isn't something that you necessarily would always have to do, but it has to do with how we typically chain the assignment operator and what we want to allow versus not allow. And the idea is that the assignment operator associates from right to left, right? So unlike some of the other operators, it associates from right to left. And so when you think about, chaining, which chaining means cascaded member function calls, so it means that we're going to do it in that order, right? So if we're chaining a bunch of assignment statements like this together, then we're going to do, for example, C4 equals C5 first, right? And then take that result and assign that to C3, and then take that result and assign that to C2, and then take that result and assign that to C1. So of course, in this case, if we do something like this, what we're really saying is that we want, in effect, we want C5 to be copied to all the other objects, right? So because we're going to copy C5's values, right? In this case, X and Y over to C4. And then after that, C4 is a copy of C5, right? And we make C3 a copy of C4. And then after that, it gets to C2 and after C1. So the end result is that all four of C1 through C4 are now going to be copies of C5. Oh. Yeah, so whenever you see, or an operator, yeah, plus, plus, or minus, minus, where there's no argument, and the return type is a reference, then that would be prefix is a member version. Or if you see for either op plus plus or minus minus with the integer as the only parameter and return type by value, then that would be postfix. And then the difference between those two and the corresponding friend versions is that with both of the friend versions, right, meaning prefix or postfix, you still have to have the parameter for the class object, right, which normally you would pass by reference, so that way you don't make a copy of it. So, but same distinction there, right? With the friend versions, both of them are going to take in the chord object by reference, but the postfix version is going to have the dummy integer parameter and return by value. And then the prefix versions is not going to have the dummy parameter and return by reference. So we are returning this as in terms of a constant, right? Returned by constant reference. But this is still okay for this type of chaining, right? Because, for example, you call op equal first with C4 as the left operand, C5 is the right operand. Um, that's going to copy X and Y from C5 over to C4, and then return a constant reference back to C4 in this case, right? Because if you think about this function call here, uh, since we're saying return star this, that means return relative to the current object, which would be C4, since that's the left of the two in the function call. So returns a constant reference back to C4, which when you do the next assignment, right, that would be on the right-hand side when you're doing C3 equals for the next call to op equal. And we can certainly have a constant value show up on the right-hand side of an assignment statement, right? We just can't have it on the left-hand side of an assignment statement. So since the operator associates right to left, then we're still going to be able to do this type of chaining uh, with op equal, even if the function returns the value by constant reference, right? So still returning a reference to the current object, right? It's just being treated as a constant reference. So the idea is that we can use this to restrict what you might sometimes call left chaining. So that's the difference between having the const in the return type or not having the const in the return type. So it's left chaining that is what we're really restricting here. So with the something along these lines where we put the C1 equals C2 inside parentheses to force that to happen first, right? Because we know that in general, parentheses can be used to control the order of operations. So what that's doing then is we're going to do the function call to op equal with C1 and C2 first, where C1 is the left operand, C2 is the right operand, and then return a copy, in this case, back to C1. But the problem now is the return value is a constant value, right? That would be showing up on the left-hand side of this assignment statement with C3. Okay, so a lot of times you'll see op equal implemented for that reason, like this. So, because if you want to restrict that type of left chaining, meaning restrict things like this, then we need to have const as the return type. So if we do that, then the right chaining, which is how op equal is normally used, right, with the statements like this, is still going to be allowed, but not something like this is not going to be allowed. So that's um, the difference in terms of what having const in the return type changes. So without the const, you'd be able to do, left chaining or right chaining. But with the const, we can't do the left chaining because, right, you'd end up with a constant value on the left-hand side. But we can still do the usual right chaining, since when you do that, the constant values at each point in the chain, right, are always going to show up on the right-hand side of the current call to op equal that's taking place. So that's a little bit more detail there with op equal compared to some of the others, and why we have that const here also in the return type. And then down here we have the input and the output operators, which are a little bit different compared to some of the others that we've seen so far. But this is another case where you'll notice that we're doing it as a friend function. So in the header file, those were both under friend, right? And here was the prototype, both the friend declaration and a prototype really at the same time, right? So this is what we did for the input and the output operators, meaning the less than, and greater than. And now the idea is we want to be able to, use this with things like C in and C out. So just in the same sense that you can, if X is an integer variable, we can say things like C out X and certainly print out its value. Or we could do things like C in X if we want to get user input and store that in X. Well, we want to be able to do the same kind of thing with a coordinate object. So in this case, if we're outputting a coordinate object, we want to show X and Y. Or if we're inputting a coordinate object, we want to take inputs and build them into both X and Y. And so here, what we're seeing is you do want to think about things like cascaded, member function calls or chaining, because like with a lot of these operators, it comes up here again. And we know that cascading is something that you can set up with the return type of the function, going back to where we first saw this idea back in chapter 9, and we've seen it come up a lot again here with operator overloading. But so the intention is that we're going to be able to, if we have, for example, multiple coord objects, we could see out them all on one line, or see in them multiple coord objects on the same line. So it is cascading, but it's different, right, than the way this has come up in the other functions. Because you have to think about, well, how exactly is the chaining working? Well, when you have a statement like this, right, if we're going to do something like C out, C1, C2, C3, Well, the first function call is going to be this call to operator less than, with cout being the left operand and C1 being the right operand, which is also why these need to be done as friend functions, right? Because you can see from this that whenever you do a call, for example, when we call the less than or the output operator, the left operand is always going to be something like cout, right? Not a coordinate object. The coordinate object is going to come on the right-hand side. So it needs to be done as a friend function, but we also have to think about, well, what's the return value then? Well, it's definitely not going to be a coordinate object, right? Because, if we did something like that, then think about what that would mean for the next thing in the chain, right? Because when we get to the next call, to the next occurrence of operator less than, where C2 is going to be the right operand, well, we can't have a reference to C1, right, as the left operand, because we need a reference back to cout, right, to output the next, the next coordinate object in the chain. So the return type then corresponds, in this case, to cout, right? Because we know that, cout is from your output stream, cin is your input stream, which corresponds to those two types, right? O stream and I stream. And so that's what we need to do in terms of the return type. And as usual, it's going to be a reference rather than a value. So that way we can keep building up the stream, right? Either the output stream or the input stream with however many different objects that we want to include there. So for the output operator, we're going to have return type O stream ampersand. And then for the input operator, meaning the greater than, we're going to have return type I stream ampersand, where O stream just stands for output stream, I stream stands for input stream. And those types are also show up in the parameter list, right? Because that's also the type of the first parameter, right? So we need to have for the output operator, we need to have that O stream show up for the first parameter type, because again, we know the function call is going to be something like cout on the left and then a coord object on the right. So the first parameter here is a reference to cout. And then a reference to cout is also what we return back to get to get ready for the next function call in the chain, if we are going to in fact be chaining it with cascaded member function call. And so that's the prototype of these two functions. So again, O stream for output stream, I stream for input stream. And I mean, it wasn't shown here, but you could also imagine applying this to things like, if you were doing like file input or file output, with your things like your IF stream or OF stream types here. But for now, we're just focusing on console input, console output, but it'd be a similar idea, just in the same sense that you can use these same operators, the less than, and greater than, with primitive variables in terms of file input, file output, right? You could apply the same concept in terms of writing a coord object to a file, for example, or building a coord object from input coming from a file using things like type OF stream and type IF stream in a similar way. But here, these two prototypes are very similar, except for the fact that we're using I stream for the input operator, and then O stream for the type for the output operator. And then we also can see that in one case, the coordinate object is passed by constant reference, and in the other case, the coord object is passed by regular reference. And it's always good to think about why that is, right? So why are we able to pass the coord object by constant reference here, but then here we're just passing it by regular reference, right? So why are we able to do that? Well, it always comes down to whether the object is actually going to change or not. So it's always, you should always use const whenever it's possible to do so, meaning when the thing that you're making constant does not need to change. And so in terms of the output operator, um, meaning a statement like this, where we're potentially chaining multiple coordinate objects, um, that's not going to change anything, right? With regard to the coordinate objects. Whereas the input statement, um, meaning something like this, is going to be changing the objects, right? Because you're going to be building the objects from user inputs. So that's another slight difference that comes into play here too, is that for the output operator, um, if we want to be following the principle of least privilege, right, which we've talked about before, we certainly should make that constant, right? Because the principle of least privilege says that if something does not need to be changed, then the function should not have the ability to change it. So for the output operator, we can have the coord object constant, and then in the input operator, it's not going to be constant since that one does need the ability to change it. So very similar, right, to all the issues we talked about before with cascading, except now it's not the class object um, itself that's what we're using as a return type, but rather a reference to either cout or cin, because that's how we're building up our output stream or input stream. Um, so that's why here, and then the points that we made here for the output operator, right, apply in a similar manner for the input operator. Um, so the return type is always going to have to be a reference to either O stream or I stream. And that's also the type of the first parameter. So that's why also these operators have to be handled as friend functions. Okay, so that's the general idea here. So they have to be friends, similar to um, things like the addition function where the integer came first and the coord object came second. Same issue here again, but it comes up in a different way. So since the coord object is not the left operand, right, these are both going to need to be done as friends. The return type is going to be O stream ampersand for the output operator, which is also the type of the first parameter. And in a similar way, for the input operator, the return type is iStream ampersand, which is also the type of the left or first parameter. Um, so these are both for things like console input and console output. And then with that, we can go and look back at the implementations here again. So not too long, like most of the other functions. So starting with the output operator here, notice that what we're doing is we're just building this stream. So the name that we gave the first parameter, which is, this is the one that's a reference to cout, we called it output. And then notice that we're just building a stream here, an output stream, where we refer to X and Y individually. So output, right, less than operator. And then here we have a little bit extra also because we're wanting to put the coordinates in a set of parentheses. So the output here is we're going to have a left parenthesis, and then the value of X, and then a comma, and the value of Y, and then a right parenthesis and a line return. But the key thing here is that with any type of output type operator, when you're overloading it, the key thing is that we need to refer to both X and Y individually, and then just return that reference back to cout. And then in a similar fashion here for the input operator, we're building an input stream where we individually refer to X and Y with the greater than operator, or the input operator. So input is the name that we used here, and input is just a reference back to CN, right? Because that's how we're going to call it, is with CN. And then we just individually refer to X and Y here, and then return that reference back to CN. And so just like all the other overloaded operators, it's always comes down to a matter of individually handling each member variable, right, within the operator function. So that way you don't have to individually handle them in the application program, right? Because the goal of all these things is to simplify the application program logic, right? So we're doing more work on the class side, but then that reduces the amount of work that we have to end up doing on the application side. So just refer to both X and Y individually. Okay, and then here we have an example of the less than operator, but that's similar to things that we've seen come up, like the equal. So this is another one that has return type bool. And it's also one where we can use const in multiple places. So here we're making the function itself const, meaning the current object is being treated as constant. And the other object involved in the comparison is also constant, since we don't need the ability to change either. And if we want to be in line with the principle of least privilege, then we should be making all those things constant. So this is similar implementation to what we've seen with some of the others. Again, it can be done with really just one line in this case. So do that comparison, which returns a Boolean value, meaning compare the X's for the two objects, the current object and C, and then do a comparison between the current object's Y value and object C's Y value, and then just AND them together, and then return that as the final Boolean result. So that's similar to some of the others that we've seen, such as equal and not equal, right? And then we could do the others like the greater than or less than or equal to, but they're all very similar in terms of implementation. Okay. And again, that summarizes a lot now of the general idea of the chord class. So just to recap a little bit from last week, we did look at all the arithmetic operators last week, and you might recall that they were all doing a statement very similar to this. Because with the arithmetic operators, we know that if you're just saying something like C1 times C2, right, or C1 plus C2, that does not change either of the two objects involved in the operation, whether it's addition or subtraction. We know that if you want to actually change the object itself, in terms of your operators, right, then you have to use one of the operators that would actually normally change the object, right? Like, for example, the greater than for user input, or the assignment operator, or things like plus equal, minus equal. So all those, right, are going to change the left operand, but the arithmetic operators by themselves do not, right? So that's why, as we mentioned last week, those operators all return by value rather than by reference, because we want to create a brand new object such that, for example, we took the two objects that were passed in and multiplied their x values together and multiplied their y values together, and that's how we build the new object. Or in the case of this one here, we passed in an integer and a coordinate object, and then we built it that way by multiplying C's x value against the integer that was passed in, and then C's y value is multiplied by the integer that's passed in, and then we create a new, brand new coordinate object, which we're going to return a copy of, right? So we know that anything that we create, locally inside the function is going to be destroyed when it goes out of scope, but that's okay because we're still going to be returning a copy of it. And that was what we did for all of the arithmetic operators. So that's why all of these we're going to return by value, meaning return type chord. And they were all, again, very, very similar to one another. With a little bit of an exception is that we did a little bit more with the operators related to division, meaning the divide operator, which gives you the quotient part of integer division, or the modulus or percent, which gives you the remainder part. For those, we did a little bit more. We had a little bit of exception handling because we wanted to make sure that we don't try to do something like divide by 0 when we're doing division related to our coordinate objects. And so with those arithmetic operators, we checked if anything related to the second argument used in the division, meaning the denominator used in the division, if anything related to that was 0, then we threw an invalid argument exception. Otherwise, we would just return the chord object as we normally would. And so, again, the idea was that if anything related to the denominator, so whether the denominator is a integer or a coordinate object, if anything related to that is 0, then we throw the exception. Otherwise, we just return the chord object. So there's a little bit more in that sense for the division operators, but other than that, they were the same general idea as the others. And then another thing that we did here was the that caret or up arrow operator. We did that, but we did it in terms of exponentation, right? Which that operator does not normally do exponentation, but we did that here with the help of the POW function to, for example, take the power x's value of the current object to the power of C's x value for this one down here, and then take y's value for the current object and then raise that to the power of object C's. And so that's how we did that operator. Okay, so those were the arithmetic operators. And then other things that we saw also last week is we saw the fact that in some cases you can you can overload an operator in terms of another operator. So we know that it's possible in general, right, for one operator function to call another. And so we saw an example of that last week with op not equal, where we implemented not equal in terms of operator equal equal, meaning the equality operator, which was shown on this line here. The idea being that if you write a statement like what we have here, with star this equal C, that we know that that's going to call, right, op equal equal, in the same way that doing a statement like that in the application program would trigger a call to op equal equal. So the idea here is that one way that you could handle not equal would be to first call op equal equal, and you'd be passing in this case, the current object as the left operand, and then the other object, C, as the right operand, and then get that Boolean value, and then just negate it. And so that gives you an idea of how we can do that, because sometimes, depending upon what you're overloading, it may be convenient to have one operator calling another to implement it that way. So with operator not equal, you could implement it directly in terms of logic, which is shown on that line that's commented out, but you can also just take advantage of op equal equal and do it that way as well. Okay. So that's summarizes the chord class here, really. So we'll look at a question now, and then we'll look a little bit at the application program too. Okay, so if you go to practice question, like before, that'll pull up your question. So here we're given a sample coordinate object and then some potential statements that we might have in the application program. So we have object C1 and then we have some C out statements, and then the question is really about what's going to be the output of the program. So go ahead and pull that up under practice question, and then we'll have you answer in a moment here. And if you see one of the older questions that we looked at from, like, for example, last week, then you can just answer it real quick and then the new question should come up. So you want to make sure that you see this question here with the coordinate object. And we'll do it a little bit differently this time. So you should right now see something pop up in Zoom where you can choose one of the 4 options. So we'll have everybody answer it here on Zoom, and then we'll show the results. So a little bit different than Kahoot. So you can actually answer it as soon as you've decided on your answer. So you don't have to wait, and then I'll let everybody know when we're gonna get time to finish up and then show the results, and you'll need to definitely have your answer in by then. But again, you can go ahead and answer as soon as you like to, right? You don't have to wait in this case. So just go ahead and pull up the question and then come and answer the question on Kahoot or on Zoom. Yeah, if that happens, just answer it. If it's one of the older questions, like the constant question, just answer on Canvas real quick and then go back into the practice quiz, and then the new question should show up. Mm-hmm. Okay. Okay, there's the question as well. Okay, go ahead and answer if you haven't, and we'll look at the results here in a second. So please go ahead and answer on Zoom if you haven't answered yet. Okay, so now your poll screen should change. So now you should see the options and the breakdown. Um, so it looks like most chosen was option B, and then a few on some of the other options. Okay, so let's go and look at the question. Then we can look at option B first. And so really question was about things like prefix and postfix behavior. That should have and so we start here with this chord object where we have 93 for X and then 44 for Y. And then we can look at option B since that one was chosen the most here. And the first thing says C out C1 and then minus minus. So meaning a postfix type operation. And so with option B, we're saying that you're going to print out the values before any decrement took place, since it's a postfix rather than prefix. So with option B, then we're saying that it would still be the 9344, and so yes, right, because since it's postfix, we're going to see the original values of X and Y on that particular C out statement. So we're going to see 9344. And so that would, based on that, then that's going to rule out A and C at least, since it's postfix behavior. So now it's narrowed down to B or D. So we get 9344 on the first line. Now the second line, and there should be a semicolon there too, but the second line is just C out C1. And so now at this point, we are going to see the new decremented values because the previous statement is now completed, right? So if we do another C out statement with C1, now we're going to see those new values. So on the next line, then yes, since we previously decremented both X and Y, now we're going to see the 92 and 43. And so far, that means it's still between B and D in terms of which one's correct, because they both are still the same at this point for the first two lines, with 92 and 43 for the second line. Okay, but then the third line is C out, and then we have unary minus, right? The negation operator to the left of C1 there. So C out, negation of C1. So on line 3, we have negative 92, negative 43. Yeah, because we're negating, we know that with that operator, right, with unary minus, we're going to negate both X and Y and then return that as a new object. But there's a difference right on the fourth line between B and D. That's where the difference between B and D comes into play. So with D, and the fourth line is like the second line, right? Just C out C1, the object C1. Now with option B on the fourth line, we have 9243. With option D as in dog, we have negative 92 and negative 43. So it's a matter of whether the third line is, meaning this line, is actually changing object C1 or not changing object C1. But we know that with the arithmetic operators, including things like the negation operator or unary minus, that is not changing the object itself, right? But rather we are returning creating a new coordinate object such that we're negating both X and Y in that new coordinate object. But if we refer to C1 again on the fourth line, right, we're still going to see the values that are not negated, because we know that a statement like minus C1 does not change C1 itself. it in effect just returns a new object. So if you want to actually save those values over the long term in the application program, then you would need to combine that with the assignment operator. But we're not doing that in this case. So when we get down to the fourth line, we're still going to see positive 92 and positive 43. So based on all of that, then yes, option B here is going to be correct. Because it reflects everything correctly at all points, right? So it correctly reflects how the postfix behavior is going to work. That is changing the current object, but you won't see those new values until the second line, right, of output. And then the unary minus or negation operator is not changing the current object, meaning it's not changing C1. So based on all of that, then yes, option B here, which was the most chosen one, was also the correct one. Okay, any questions before we go to break? Okay. Okay, we'll take about a 12-minute break until 1:08. So take about a 12-minute break and then come back at 1:08 and continue.